Welcome folks. In this video we are going to have a journey through science paper 1 for the year 2016, and this paper was written by the internal candidates. So we begin with section A. The diameter and the length of a thin wire, approximately 50 centimeters in length, is measured as precisely as possible. What are the best instruments to use? So whenever we are dealing with a diameter, we know that a diameter is a very small number if we are dealing with a thin wire. So this one has to do with micrometer screw gauge. Then for the length, we can use the meter rule. So our correct answer here is just C. So the diameter, micrometer screw gauge. Then the length, we can use a meter rule. Then we move on to question 2. Which of the following is the standard unit for time? So the standard unit for time is just a second. Have question 3. The diagram below shows a speed time graph for a car. Okay. Then at which points is the car moving with zero acceleration? So it is at point. So for us to have zero acceleration, we need to have the constant velocity. So from the given graph, which point or points can we tell that at this point the car was moving with a constant velocity? So here we have a constant velocity. So if we have a constant velocity here, then the acceleration will be 0. Then where else? At this point. At this point, we have also a constant velocity. So even the acceleration will be what? Will be 0. So the answer is A and C. Now question 4. When a nut and bolt are difficult to undo, it is easier to turn the net by using a longer spanner, because the longer spanner gives the first one less friction, more friction, a large turning effect. So the answer is C. So it has to do with the moment here. Then we have question 5. A body moving with a speed of 30 meters per second has kinetic energy of 1800 joules. What is its mass? So let's have the formula. So kinetic energy is equal to half mass times velocity squared. So the kinetic is given is this number. So we can now substitute. So 1800 joules is equal to half. Mass is what we are solving for. Velocity is 30 times 30, since we have a squared here. So we have this number is equal to half of m. So 30 times 30, we can just say 3 times 3 will give us 9. Then we have 2 zeros. So we can now say 2 here is 1. Then 2 here will give us 450. 450 times m, we get 450 m. Then is equal to 1800. So to isolate m, we divide by 450, also by 450, so that if we cancel, our mass is equal to 1800 divided by 450. So I'm getting 4 kg as my final answer. So the answer is C. Which of the following properties of a body is affected by a change in gravitational field strength? So if you look at mass does not change. The mass is constant regardless of the position where you place an object. Then if you look at the temperature, so temperature cannot be affected by gravity. Temperature is affected by the amount of energy applied to a given object. Then volume, this is just the total amount of space occupied by a substance. So the only property which can be affected by change in gravity is weight. For example, if we have an object with a mass of 10 kilograms on Earth, if we are to calculate the weight, would be 10 times 10, which is giving us 100 newtons. Then if you were to calculate the weight on Moon, would be 10 times the gravitational is 1.6, which is giving us 16 newtons. So we can see that weight changes because of gravity, or we can say weight is affected by gravity. The greater the gravity, the greater the weight of an object. Then for question 7, which substance A, B, C or D below is a liquid at positive 200 degrees Celsius. So let's look at these numbers. Is a liquid at this. So below this number, we are expecting to have maybe a solid like an ice. So negative 280, negative 39, that will show us something to do with an ice. So between these two numbers, we can make our conclusion. So 20 is liquid. So if we start decreasing the temperature up to negative 39, that will change into a solid. Then if this is a liquid, if we increase, so our answer is just B. We move on to question 8. A boy strikes a rail with a hammer to create a sound along the rail. A girl listens with her ear against the rail. 1 second later, the girl hears a sound through the hair. So after a second, this is when this girl heard a certain sound in air. Now the question is, how long will it take for a sound to reach the girl through the rail? Now remember, if you look at the nature of particles in gases, we know that the particles in gases are far apart. Now if you look at a rail is a solid, and particles in solid substances are closely packed, and the speed of sound depends on the arrangement of particles. So the closer the particles are to each other, the greater the speed of sound. So we are not expecting the sound to travel at the same speed in air and in a rail. So in a rail, the sound will travel faster than in a gas, according to science. So we are expecting it to have at least less than that second, because 1 second was the speed of sound in air. So we are expecting to have less than 1, which is our answer is just D. Then question 9, which of the following waves belong to the same class? Okay, so if you look at the light wave is a transverse, radio wave is a transverse, water nipple is a transverse. So this is our answer, because B, sound wave is a longitudinal, then these two are transverse. So this one is not the answer. Microwave is a transverse, infrared is a transverse, sound is a longitudinal, so this is not the answer. Gamma ray is a transverse, sound is a longitudinal, so the best one is just multiple choice A. Now we move on to question 10. Water waves are produced with a frequency of 5 Hz by hitting the water surface with a tip of a pencil. If the water travels 30 meters in 60 seconds, what is the wavelength of the wave? So we know that velocity is equal to frequency times the wavelength. So we want the wavelength, we divide by the frequency, also we divide by the frequency. So if we want to calculate the wavelength, it is the velocity divided by frequency. Now remember, frequency is given 5 Hz. What we just don't have here is we don't have the speed. Now we can find the speed since we are given the distance, the total distance, and the total time. So we'll say speed is equal to distance over time. So the distance is 30 meters, time is 6 seconds. So if we divide, this will give us 5 meters per second. So where there is v now, we can put our speed, which is 5 meters per second over the frequency is 5. So 5 into 5 is 1 meter as our answer, which is just B here. Now question 11. The diagram below shows a beaker of water containing a red crystal which slowly dissolved. Okay, so which slowly dissolved. Gentle heat was applied below the crystal. Okay, then the red color is seen to rise. What is the name of this process? So after that dissolving, then we are told the red color was observed to rise. So this process should just be convection, because we are dealing with the movement of molecules, the movement of heat in a liquid. So that is just convection. Then we have question 12. Which characteristics describes an image formed by a plane mirror? So we know that a plane mirror produces an image that is virtual. So virtual. Now let's look at the first one, real and inverted. No, virtual and upright. This is correct. It's virtual and also upright. Then in terms of the size, the image produced by a plane mirror is the same in terms of the size as the size of an object. So that is what we are supposed to know. Now we move on to question 13. The question reads, the diagram below shows a ray of light directed at a plane mirror. What is an angle of incidence and the angle of reflection? So the first one, let's draw a perpendicular line to the surface, and we know that we call this one as our normal ray. Then we are going to have reflected ray in this direction. Now the angle of reflection is formed here, then angle of incidence is here. Now remember, the normal ray is perpendicular to the reflecting surface, so the total angle that is formed between the surface and the normal ray is 90. Now to find the angle here, we'll say 90 minus 40, we get a 50 degrees. Now remember, whenever you are dealing with reflection, the angle of incidence is equal to the angle of reflection. Since there is 50 here, this also means there is 50 here. So we need to have same values. So the answer is just D. Number 14. Which law describes the case with which iron or steel can be magnetized and demagnetized? So let's begin with A. Metal ion magnetize easy, demagnetize easy. We want even which law describes the case with which iron or steel can be magnetized and demagnetized. From my observation, A is the answer, because iron is easy to be magnetized and also easy to be demagnetized. Then B is not the answer, C is not the answer. Then I think D is also the answer, because if you look at steel is difficult to magnetize and also difficult to demagnetize. So for this question, I think this should be a free mark. I don't know, you can write in the comment section below what you think of this question. Maybe I might be the one, but from what I know, we say steel is hard or difficult to magnetize and also to demagnetize. So D is the answer, A is the answer according to my observation. Then we move on to question 15. A permanent magnet is placed on a flat horizontal surface. A plotting compass is placed on the dot as shown in the diagram below. So permanent magnet, then we have plotting compass placed here. So what we have to look at whenever you are dealing with this is that the arrow of the plotting compass has the north pole. Since this point is the one in contact with the south pole of the magnet, we are expecting to have the attraction here. So if this is the attraction, the answer is C. My point is we are not going to have a deflection because our compass will still remain in that direction because of the force of attraction. Then we have question 16. A positively charged rod is held close to but not touching an insulated metal sphere. Then this is positive. So we know that this metal sphere has charges that were evenly distributed. Now after you bring something that has a charge, the electrons and the protons now will move according to whatever that is in contact. So here we are going to have the electrons will move to this region due to the force of attraction. Then the protons will move to this region due to the force of repulsion. So we can say that our answer is D. Then we have question 17. A 60 volt battery is connected to 4 resistors as shown in the diagram below. What is the energy dissipated by the 4 resistors in 2 seconds? So we know that the energy is calculated by voltage times current multiplied by time. So now here this is we have a combination of connections here. So if 60 volts is at this point, remember that in this direction we are going to have 60 volts. Also in this direction we are going to have 60 volts because we know that voltage is equal in a parallel circuit. So we have a parallel connection. Now our focus is in this direction. Now we don't know from that 60 volts, we don't know how much of it was used by the 3 resistor. So let's say this is resistor 1, then we'll say resistor 2, then we'll say resistor 3. So we don't know how much of that voltage was used by the resistor 1. So what can we do? Let's find the total resistor for resistor 2 and 3. So let's find this. So we know that we'll say total resistor is equal to resistor 2 times resistor 3 over resistor 2 plus resistor 3. So resistor 2 is 4 times 12 over 4 plus 12. Resistor 2 is equal to 4 times 12, we get 48. So we get 48 over here we are going to get 16. So 48 divided by 16, you get 3. So this means that the connection now is like this. So we have it now in a series. We know that here we have resistor 1 has 3 resistors, then the combination of these 2 resistors 4 and 12, we have this one. So how can we find the total resistance? So the total resistance will be 3 ohms plus 3 ohms. Then our total resistance is equal to 6 ohms. This means that if we combine these to make it 1, we are getting 6 ohms. So why do we need this? We want to find how much current went in this direction. So we can now say voltage, we are finding current for now. So current is equal to voltage divided by total resistance. So what's our voltage? we know that the voltage is 60 volts over total resistance is 6. Then the current here will just give us 10 amps. So this means that 10 amps went in this direction. So we have 10 amps. Now we don't know how much of that went in this direction, also how much of that went in that direction, because we know that whenever we have a connection in parallel, current divides according to the Kirchhoff's loop law. Now, since we have the current, let's find how much of voltage was used by these 3 ohms. So say voltage is equal to current times the resistance. So the current is 10, resistance is 3. So this giving us 30 volts. So this means that from that 60 volts, 30 volts was consumed at this point. So at this point, the remainder is just 30 volts. So now here we are going to have 30 volts in this direction, also 30 volts in this direction. Remember, voltage is equal in parallel. So at least we have the voltage that went in this direction. So say energy is equal to the voltage, we have it is 30. Now we need to find the current that went in 4 ohms resistance. So how much of that current went there? So it's simple. We can say current is equal to voltage over resistor. So voltage we know is 30 over resistor is 4. So 30 divided by 4, we get 7.5. So from 10 amps, 7.5 went in this direction. So 7.5 is what we are going to put here. Then time is given 2 seconds. We can now punch it at once. So 30 times 7.5 times 2. So according to my calculator, I'm getting 450 joules. Our answer is just C, B. Then 18. The diagram below shows a horizontal beam of electrons entering a region between 2 charged plates. Okay, so in which direction is the electron beam deflected? So the original direction of the beam, electron beam. So we can see that we have electric field line, this. Now the beam, electron beam is coming in this direction. So what happens when electrons enters an electric field? So what happens in terms of that is what we are trying to focus here. So here the diffraction will be in this direction. So why? Because you know that electrons have the charge of minus, and here we have a positive, so there will be that attraction, so they will deflect upwards. Then we will have question 19. A sample contains 12,000 radioactive atoms of a particular nuclide. After undergoing 2 half-lives, how many atoms have decayed? So the original is 12,000. So let's look at the first decay. So the first decay, you just multiply by half or divide by 2. So the first decay will give us 60,000. This means that the first 6,000 have decayed. Then the second decay will give us 3,000. So we can see that the first decay is 6,000 decayed. The second decay is 3,000, which is adding up to 9,000 as our answer. So our answer is just C. Now we have question 20. A nucleus is represented by this Z. It emits 1 alpha particle followed by 2 beta particles. What is the resulting nucleus? So we have Z 230, 91 alpha particle. So we know that the mass number we subtract 4, so this will give us 226. Then the atomic number we subtract 2. 91 minus 2 will give us 89. Then we can just say A plus this. So remember, this is just an indication that it emits an alpha particle. So this is our parent atom, then this is our daughter atom. Now for the second decay, the daughter atom now will become as our first, as our parent. So we have 226, then 81. Now remember, followed by 2 beta. So let's look at the first. Now under beta decay, the mass number does not change, the atomic number increased by 1. So we go back to, we go to 90, then we'll just say B plus C. The notation for a beta particle is just this symbol. So this means that the beta particle, if you just study it carefully, you would understand that it is just a fast moving electron. That's why we have this symbol here. Then let's look at the second emission. So this second emission we have 226. The mass number will still not change. Then here 91. We'll say C plus C. So the total number of decays that were done were 3. The first one, alpha, which is, this is our first one. Then the second 2 beta particles are these. So what we are looking for is something with this number. So we are not interested with the letter that was used. Our focus is we are going to get an answer with the mass number of 226, then 91, which is just A. Now we move on to question 1 from section B. So figure 1.1 shows a measuring device. Okay. Then name this measuring device. So you should not only be familiar with how to calculate the readings of a vernier, micrometer screw gauge like this one. You should also be able to identify. So this is a micrometer screw gauge. So if you study this stuff carefully, you'd find that the word micro means something that is very small. Hence, micrometer screw gauge is an instrument that measures a very small length. Then for B, what is the reading shown on the device? So the reading, first we'll begin by finding the main scale. Then from there, the vernier scale. The word vernier does not only mean, or you shouldn't only associate it with the vernier caliper. The word vernier means something that is moving. So the vernier scale is here under this instrument. So we have the vernier scale here, then our main scale here. So we begin with the main scale. So the main scale, you need to focus on these calibrations on top. So here we have 5. So this is 6, 7, 8. Now the last one is 8. Now below, if there is this small line here, you add 0.5. So this becomes 8.5 millimeters. Then we move on to vernier scale. So vernier scale, we are supposed to end, this line should coincide. So this is where we are supposed to end. So 20, 21, 22. So 22 you multiply by 0.01, which is we get 0.22 millimeters. Then from there you just have to add. So if you add this, you get 80.5 millimeters as our final answer. Then state 2 precautions to be taken when using this device. So the first one, you make sure by making sure. So by making sure that readings, before you do anything, it has to read a 0. That readings are 0. Or we also simplify this one by just say by zeroing this. So before you do any measurement, it has to show a 0. So that's what we can do. Then for the second one, we have 2. We can say by thorough cleaning. So before you place whatever that you are trying to measure, make sure you clean it, because a micrometer is very sensitive. It can even measure a dust particle. Now we have question 2. A stone of mass 1.0 kilograms is dropped from a certain height and takes 8 seconds for the stone to strike the sand ground. Upon reaching the ground, the stone penetrates 5.0 centimeters into the ground. Take gravity to be 10 meters per second squared. Calculate the height from where the stone is dropped. So let's draw a visual diagram. So this is our, this is our building, and we are given the stone was somewhere here before it was dropped. Then the height in between the original point of the stone and the ground, we are given, that's what we want. Okay, so that's what we want. We don't have, so say S, we just call this S for displacement. So let's look at what we have. We have mass. We don't have final velocity, but the initial velocity is given. So whenever an object is dropped, its initial velocity is 0. Time is given is equal to 80 seconds. So here we are going to use the equations of motion, where our first equation is final velocity is equal to initial plus 80. The second one is displacement is equal to u plus v times t over 2. The third one is s, which is displacement is equal to ut plus half at squared. Then the fourth one is just v squared is equal to u squared plus 2as. Now let's look at the data collection. So data collection will give us which formula is applicable. So say SUVA t. So t is for time, 8 seconds. A is for the acceleration. So whenever you drop something, the acceleration is 10. Final velocity we don't have. Initial we have, it is what? 0. Then displacement is what we are solving. Now whenever you don't have the final velocity, the formula that is applicable, so you need to select an equation from the 4 equations with which has an s in it but does not have a v. Why? We can't solve 2 variables at once. So we can see that this is our formula that we are going to use. So say s is equal to ut plus half at squared. Then we know that our u is 0, our t is 8 plus half, our a is 10, our t is 80 squared. So we know these times will give us a 0. So half of 10 will give us 5. 8 times 8 will give us a 64. Then 5 times 64, I'm getting 320 meters as the height. Now, the other way we can simplify our formula, whenever the question is find the height, and if an object was dropped, this formula, since we know that whenever you drop something, the initial is always 0. So if we put where there is u, we put 0 times t plus half. Now the acceleration, whenever you are dropping something, the acceleration is g. Then we have t squared. So this will cancel. So the formula, the simplified formula, is just half g t squared. So this is the formula that you can use. Now we move on to question B. Calculate the kinetic energy of the stone on the ground. So for us to calculate the kinetic energy, we're supposed to have the final velocity. Now of which final velocity we don't have that final velocity. Now what can we do? So we know that the height, this time we have it. The height is 320 meters. This is our height. So what we can do is, let's find the potential energy before the stone was dropped. We are given from the data that the mass was 1.0 kg. Let's check. Yes, we have this number. So the mass was 1.0 kg. So let's find the potential energy at that. So potential energy is equal to mgh. The mass is 1, gravity is 10, height is 320. So if you multiply these numbers, you get 3,200 joules. So the potential energy at this point is 3,000 this. Now, after this stone was allowed to fall freely, the potential energy started to change into kinetic energy, because potential energy cannot stay in an object that is moving. So we need another form of energy. So the potential energy will start to be converted into kinetic energy. If this object, which is our stone, covered half of the original distance, half of the potential energy will also be converted into kinetic. Then if it continues falling down, the point or the time at which now this stone is hitting the ground here, all the potential energy will be converted into kinetic energy. So our kinetic energy at that point is just 3,200. Then remember, at this point our potential energy is what? 0. Then our C, calculate the average retarding force. Average retarding force. How can we find that average retarding force? So we know that force is equal to, we'll say, mass by acceleration. Mass is given, so we need to find the acceleration. So let's go back, we'll see. Okay, so there is this point, the stone penetrates 5.0 centimeters into the ground. Okay, so this point is very important if we just miss it. So let's say this is our ground. So upon reaching on the ground, we are told the stone penetrates up to at a point where it stopped. So the distance that it covered from the ground to this point is 5 centimeters. So when the stone hit the ground, as it was penetrating, the speed started to reduce until it came to a point where it rested. So at this point, we have now new data. So let's collect the new data. So the new data is, we have sovereignty as usual. Now at this point we don't have time. Remember, you don't have time. So acceleration we don't have. The acceleration due to gravity is when this stone was moving before hitting the ground. So time we don't know how much it took to penetrate this distance. Okay. So displacement, we have it is 5 centimeters. Now remember to convert into meters. So 5 divided by 100 will give us 0.05. Initial we don't have. Now this point is going to be considered as our new initial. Then the rest is our final velocity. So initial we don't have, the final will be what? 0, since it came to rest. So which formula can we use to calculate acceleration? So let's go back to the formulas. So to the formulas that we have here. Okay. Okay, so which formula can we use at this point? Final velocity, initial velocity. Okay, so we have that u of t. So okay, so we can say that all these formulas have the initial velocity. So what can we do? Let's calculate the initial velocity from the original data. So how can we solve? So we'll say final is equal to u plus at. So final is equal to this final is for the when hitting the ground. So the initial at first was 0 plus the acceleration. We know that the acceleration is what? 10. Is 10 time. The time that was given was 8. So you know that the final velocity is 80 meters per second. We have this. So we can use now which formula? So let's use this formula. I need some space here. So v squared is equal to u squared plus ac. So our final is 0 at this point. 0 squared. Then here this will be 80 squared plus the acceleration is what we are solving for. Then the displacement is 0.05. So 80 squared, we have 6,400 plus 0.05. So we shift this number to this side. So this will give us 0.05 is equal to negative 6,400. We divide by this, also by this. So what's our acceleration? Acceleration is equal to, so I'm getting 128,000 negative. So the negative, this means that we are solving for retardation because it was slowing down. So say now mass is equal to 1, then negative 128,000. So if you multiply by this, our final answer is negative 128,000. So the negative is just showing us that whatever object that we are dealing with was retarding, it was coming to a stop. Then we move on to question 3. In a certain town, when the temperature was 27 degrees Celsius and the atmospheric pressure was 99,000 Pascal, a 300 cubic centimeter container was sealed. The container, which contained only air, was placed into a refrigerator until its temperature cooled to 5 degrees Celsius. Calculate the new pressure. So this is an ideal gas equation because we can see that all the three factors were changing. So we know that PV is equal to T. So PV, P1 V1 over T1 is equal to P2 V2 over T2. So since all these are changing, I just want to divide by T also here by T, so that we only have a 1. 1 is equal to PV over T. So pressure 1, what is our pressure 1? 99,000. Volume 1, 300. Temperature 1, 27. Now remember, temperature should be in Kelvin. We want it in Kelvin. So the formula is temperature in degrees Celsius plus 273. So 27 plus 273. So our temperature in Kelvin is 300. So we have our 300 here. Then pressure 2. Pressure 2. Calculate the pressure is what we are solving for. So P2, volume 2. Volume 2. Now let's look at the container which contains only air was placed into it until each temperature could calculate the new pressure until it's. So I think I've made a mistake here. We can see that we don't have volume 2. We are only given one volume. So if we are given one volume for a question like this one, then we'll say volume is constant. So we need to use another equation here. Okay, so that's also simple. Let's make our equation. So our equation will be, we know PV is equal to T. So this is what I want you to master. So since we want V to be the subject formula, let's say now PV is equal to T. We divide by P over P. So if we cancel, V is equal to T over P. The good part of this, it can be used to form any of the three equations. So volume is constant, so volume is equal to T over P. So where there is volume, we have T over P is equal to T over P. So T1, P1, T2, P2 as our formula. This formula is same as P1 over T1, so you maybe know it in this way. P2 over T2, it's the same. So temperature 1 is 300. Pressure 1, that is 99,000. Temperature 2 is 5 degrees, so we can convert. So 5 plus 273, which is 278. So temperature 2 is 278 over pressure 2. So 300 PT will give us 300 pressure 2. Then 99,000 times 278. I'm getting 27,522,000. So we divide by 300, also by 300. P2 is equal to, so we are getting 91,740 as our pressure 2. So we can see that the temperature and pressure are directly proportional to each. If the temperature reduces, the pressure also reduces. We can see by calculations here. Then we move on to question 4. Figure 4.1 shows a pulley system used to lift a load of 9,600 using an effort of 2400 through a vertical distance of 20. Okay. Then let's look at the question. Now, before we look at the question, this is where the effort must be obtained. This is where our load is. So calculate the mechanical advantage. So we know mechanical advantage is just MA is equal to load over effort. So the load is 9,600 over, what's our effort? Effort is 2,400. 2,400. And remember, these are ratios, you don't have to put units. So my mechanical advantage is 4. Okay, what is the velocity ratio? So here you just have to count the number of ropes. So have 1, 2, 3, 4, 5. Or you can count the number of pulleys. So have 1, 2, 3, 4, 5. Then what is the efficiency? So efficiency is equal to mechanical advantage over velocity ratio times 100%. So mechanical advantage is 4 over 5 times this number. So 5 into 5 is 1, 5 into 100, that's 20 times 4. So our original efficiency is 80%. Then calculate the distance moved by the effort. Let's go back, look at the data that we have. So through a vertical distance of 20. So this means that the original point where the load was to the point where it is now after being lifted, it covered a distance of 20 meters. So this is the distance moved by the load. So how can we find this distance? So we'll say velocity ratio is equal to distance moved by load. This should be moved by effort over distance moved by load. So velocity ratio is 5. Distance moved by effort is what we are solving for, over distance moved by the load is 20 over 1, we cross multiply. So distance moved by effort is equal to, this will just give us 100 meters. Can we also find this one? How can we find efficiency? Okay, this is just enough. Then we move on to question 5. Figure 5.1 and 5.2 shows the displacement distance and the displacement time graph respectively. The graphs are for a water wave in a ripple tank. State the wavelength of the wave. So let's say this is our original point. So from this point up to here we have, this is our wavelength. Or if you want, you can get it from here up to here, because we know that if we move in this x-axis, this is 0.5, then here we have 2.5. So 2.5 minus 0.5, you still get 2. Then from 0 up to here you still get 2. So wavelength is equal to 2 centimeters or 0.02 meters. So in meters you divide by 100 because we are given in centimeters. Then state the period of the wave. So the period we use figure 5.2 because we can see we have time. So the period is the time from here up to here. What number is here? 0.04. Remember, period is the time taken to make one complete oscillation. Then what is the speed of the wave? So speed is equal to distance. So we'll say distance over time. Now what's our distance? So what's our distance? Or yes, so what's our distance? We can say distance is 0.02 as our wavelength over 0.04. So 0.02 divided by 0.04, I'm getting 0.5 meters per second. Okay, let's find the frequency since we have the period. So frequency is equal to 1 over t, 1 over 0.04. So what is 1 divided by 0.04? I'm getting 25. Now we know that the velocity is equal to frequency times the wavelength. So frequency is 25 times 0.02. So 25 times 0.02, you still get the same answer, 0.05 meters per second. So you can get N. Figure 6.1 shows a laboratory thermometer. State the range of the thermometer. So the first one you can see is range is negative 10 to 110. So that's the range. Then it describes how the behavior of a more sensitive thermometer is different from a less sensitive thermometer. So a more sensitive thermometer has the ability to detect even a small amount of energy, because temperature is just the total kinetic or the average kinetic energy of a substance. So say a more sensitive thermometer has the ability to detect even a small amount of energy in a substance. Like it can detect a negative temperature. So thermometers that detect negative temperatures, they are more sensitive. So state one change in the design of the thermometer to make it more sensitive. So by reducing the diameter, so the diameter of the glass bulb. So by just reducing the diameter, because whenever the diameter is reduced, heat is easy to penetrate. If we know that this is our diameter, so let's say we make it like this, so we can see that it's easy for heat to hit the liquid inside for it to expand. Describe how a clinical thermometer differs from a laboratory thermometer. A diagram may be included. So a clinical thermometer has a constriction. Then our diagram, if we are to draw so make sure whenever you draw, if this question comes like this, make sure you draw it to your perfection. Now when putting this tube, make sure you have a constriction. Then a thermometer just measures a small range of temperature, like for the temperature of a human being. Okay, so something like this, then you put the numbers. So this is what we call the constriction. Then most of these thermometers, the range is from 35 up to 42. Okay, so we have it like that. Number 7, figure 7.1 shows a 6.0 power supply connected to two resistors which are in parallel. Okay, then you calculate the effective resistance of the two resistors. So we have resistor 1, resistor 2. So total resistance will be RT is equal to resistor 1 times resistor 2 over resistor 1 plus resistor 2. Resistor 1 is what? 4 and 12. Okay, so 4 times 12 over 4 plus 12. So 4 times 12 will give us 48 over 16. 16 into 48 will give us 3 ohms. Then calculate the value of current in the 4 ohm resistor. Let's go back. So 4 ohm resistor wants to how much of current was going through this. So you know that if our source is 6, here we are going to have 6 volts. Also here we are going to have 6 volts. Remember, voltage is equal in parallel. So how can we find current? So we'll say current is equal to voltage over resistance. So the voltage is 6 over 4. So 6 divided by 4 should give us 1.5. So our current is 1.5 amps. Then the second one, current in the battery, which is the total current. So what we can do is, we know that here is 1.5 amps. Here we are expecting to have, so say current 1. Let's find current 2. So we'll do the same. Current 2 will be voltage over resistors. So voltage is 6 over 12. If you divide, you get 0.5 amps. So therefore our total current IT is equal to current 1 plus current 2. Current 1 is 1.5 amps plus 0.5 amps, which is adding up to 2 amps. Or if you want, you can calculate the total current at once. So it can just be this. So voltage is 6. Total resistance, remember the total resistance we calculated to be 3. So we divide by 3. This is giving us 2 amps. Then would the addition of an extra resistor between A and B in parallel with the original resistors increase or decrease the current in the battery? Explain your answer. So would increase or decrease the current? What is the addition? So it will increase the current. We know that whenever we have resistors that are connected in parallel, current is easy to flow compared to, let me first understand the question. would the addition of an extra resistor between A and B in parallel with the original resistors increase or decrease the current in the battery? So this would decrease the current in the battery, because resistor opposes the flow of current, opposes the flow of current. Let's picture this one. Let's say we have a highway. Then this one, let's say we just have two lanes here. Then we have these cars that are going in this direction. Then we have these that are coming in this direction. So what I want you to picture is, picture yourself driving a car. Let's say, is it easy for you to move in an highway or in a road where you have maybe 3 cars moving in the same direction, or 2 cars moving in the same direction? You'd find that it is easier for you to move when you have 2 cars. So if you add another extra car moving in the same direction, it is going to be hard for you. So that's the principle with resistance and current. Maybe that has made a picture. Number 8, figure 8.1 shows a transformer which has a primary coil of that and the secondary coil of that. Okay, calculate the secondary voltage of the primary coil. So say primary coil, secondary coil. So the primary coil has 500 turns, secondary 25. So 500 here, 25. So we are dealing with a step down. So by what number was this number multiplied by or divided by? So for you to find the number, you just have to say 500 divided by 25. So this means that 500 was divided by 20 to give us 25. So if we have 240, the voltage on the secondary will also obey the same. So you just divide by 20. So 240 divided by 20. This means that our output voltage will be 12. Or if you want, you can do this. You can say primary, secondary. So we have 500, 25, 240, x, we cross multiply. So 500x is equal to 25 times 240. I'm getting 6,000 over 500 over 500. So 6,000 divided by 500, I'm still getting a 12 volts. So you can find it like this. Or if you want, you can say number of turns on the primary over number of turns on the secondary is equal to voltage on the primary over voltage on the secondary. So number of turns on the primary is 500 over 25. Voltage is 240 on the primary over voltage on the secondary. So we can see that we're still getting the same answer here. So you can use whichever method that you are comfortable with. So the answer will still be 12 volts. Now calculate the efficiency of the transformer if the primary current is 0.6 and the secondary current is 0. So the efficiency is equal to power output divided by power input times 100%. formula for power is equal to VI. So this will be VI. Remember, the output is secondary, so voltage on the secondary times current on the secondary over voltage on the primary times current on the primary multiplied by 100%. Then we have our efficiency. So voltage on the primary, remember, secondary, we calculated this to be 12. Current on the secondary is given 8 amps over voltage on the primary 240. Remember that current is 0.6, this number here, times 100%. So 12 multiplied by 8, I'm getting 96 over 240 times 0.6, I'm getting 144 times 100%. So 96 divided by 144, 0.666666666, 7 times 100%, which is giving us 67, if we round it off, percent. The last question, we have lanthanum 139 LA emits an alpha particle to form cesium, followed by an emission of beta particle to form barium. Express these changes using nuclear equations. So the first one, emission of alpha particle, so it's L 139.57. okay, so this should be LA. Remember, alpha decay, you subtract 139 minus 4, you get 135 here. Then 57 minus 2, we get 55. Then we are told we are forming cesium, Cs, plus He4. So this is our equation for the first one. Remember, whenever you add these numbers, must add up to this number. Same applies, this plus this must add up to this number. Then emission of beta, so cesium is our daughter now, 135, then 55. The mass number does not change, 135. The atomic number increased by 1, which is we are forming barium plus this. Also, the sum of these two numbers must add up to this. The sum of two numbers must add up to this. So this is what I wanted to share with you. So that's it for this video. Thanks for watching.